Good afternoon. I am Jesse Burke. I am a product marketing, senior manager of product marketing at Qualcomm. Thanks for coming. Come on in, find a seat. Just wanted to let out a few housekeeping real quick. If you can all silence your phones, if you please. Couple reminders as well. As you've heard many times today already, your entry to win your TV is filed through your app, your Uplink app, so be sure to do that. Also, we'll get you out of here on time to get to your next session today. So, we'll get you out about 10 minutes before the top of the hour. I think that's all I have for you guys for an introduction. So, with that, I'm going to introduce our speaker. This is Michael Stauffer, who's the Senior Director of Business Development for Qualcomm Atheros. And again, obviously, this session is really focused on the introducing the fundamentals of Internet of Everything connectivity. So, Michael, it's all yours.
Sure. All right. Yeah. Thanks, Jesse. Well, welcome and thanks for coming late on Friday afternoon. As Jesse said, we'll get this done on time so you can get to your next session or to happy hour, whichever you're choosing. So the topic today, which you've heard a lot about this the last 2 days in various sessions, is connecting the Internet of Everything. So I'm going to give a perspective a little bit from the connected home and home network type environments. So the Internet of Everything is here. Depending on which numbers you look at, they're 25 billion, 50 billion. We tend to use 25 billion permanently connected things by 2020, but whatever number you use, it's a big number, and it's a great opportunity. So what I like to think of it really as the Internet of everything else we haven't already connected, because we've been connecting things for quite a while with Wi-Fi and other technologies, but it's been things like PCs and phones and tablets and recently TVs. But now what we're talking about is really connecting everything else. And one of the issues with this market is it's so broad. I mean, by definition, it's very broad. It covers everything. Things in the home, things in cities, outside the home, industrial, automobiles. Similar technology can cross all those. Some technologies are better for some of those than others. But it's kind of a broad and confusing space. So we tend to try to group this into some manageable chunks that we can think about and address properly. And so we think of it in terms of connected ecosystems, like the smart home, the smart body wearables, smart cities, smart car, those sorts of things. So what I'm going to focus on today really is the smart home. And so when we look at what's happening and what people are talking about is IoE in the home, it's really all these new things that we haven't connected before. So door locks, thermostats, appliances, security systems, these kinds of things. There's been some of that going on for a while in kind of vertical silos, but now it's really starting to take off. And so these devices tend to have somewhat different connectivity requirements than the traditional devices we were connecting before. So with PCs and phones and TVs, we're tending to move files and media streams around the network, and that puts a lot of strain on the network. Well, these devices are different. They tend to be small packets, state and control information that's only sent occasionally. So it's a different kind of connectivity, and it needs a little bit different approach to the problem. So these devices in the home really have to play in the environment of the existing home networks and the evolving home networks. And so the typical home network today is usually based on Wi-Fi, perhaps in combination with something like Powerline, MoCA, or even Ethernet in some homes. And this network is all brought together by the smart gateway, which controls the network and is also the access to the outside, to the cloud. So now you can connect your devices in the home to cloud services outside the home. And to date you'll see various gateways out there. You'll see siloed gateways, like a security company might come and provide you their gateway. It might be cellular access to the gateway, and then some other technology inside the home. We think this will all converge over time to one smart gateway that will be the entry point for all of these services to the cloud. There's a number of advantages to that, and the approach that we've taken is to have a programmable type of gateway, running Android. You can do apps for these things and make it easy. Okay. So consumers have networks today. They've been putting these in place so they can get access to the internet with their laptops anywhere in the home. They might have bought a smart TV or an Apple TV or a Roku box, and they want to use it, in some far off corner of the home. So they figured out how to get their Wi-Fi network to cover the entire home using things like wireless repeaters and perhaps power line Wi-Fi extenders. So a lot of consumers have already done this, and we can tell from the sales figures that there's a pretty good penetration of this sort of thing. So the nice thing about that is when you now bring in these new IoE devices, wherever you put them in the home, you're likely to have pretty good connectivity. So these devices don't necessarily have to all go all the way back to the gateway. If you have a repeater somewhere in the home, it'll get good connectivity to that repeater. So what that means for the IoE devices, or the connectivity piece, is they can be fairly modest Wi-Fi. They can be 1 by 1, low power, small footprint, and very importantly low cost. Because a lot of these new devices are low cost devices, in the couple $100 range, and something like an appliance, they don't want to pay a lot to add connectivity because the user experience is still being worked out, and they're not sure. We haven't figured out what the value is yet for some of the user experiences. So cost is important. So we can get the connectivity in there and get the devices out and figure out what the market's going to pay for. Okay, so you have this reliable home network, but that's kind of step one. The other thing that you need besides this basic connectivity is really some software on top of that to pull all this together and bring interoperability to these devices at a higher level. So there's a lot of questions. How will newly connected devices and networks discover nearby friendly devices, identify services running on these devices, adapt to devices coming and going? This is going to be, you're going to have a device one day, maybe you move it to another place in the house, maybe bring a new one in, get rid of that one. You got to manage diverse transports. Not everything in the home is going to be Wi-Fi. There's a lot of Bluetooth. There's things out there like Zigbee. And so it'd be nice if you could have a higher level layer of interoperability that was PHY agnostic. And the other thing you want to have is interoperability at the OS level. You want to have something that can work across any OS. You want to be able to exchange information and services, and you want to have security. So we need to solve those problems. So ubiquitous connectivity promises to make devices smart, but only if they speak the same language. So if you have a whole array of proprietary vertical solutions that can't talk across those vertical boundaries, this is not good for the consumer. Typically consumers don't go out and buy, say, all their appliances from one manufacturer. They buy a dishwasher from manufacturer A, a refrigerator from manufacturer B, and if you're going to have connectivity interoperability amongst these devices, you can't have vertical solutions by manufacturer. So one of the answers is something that you probably heard a lot about this week is the all-joint framework that was developed by Qualcomm and is now an open industry standard. It's got a lot of traction out there, but what it really does is allows all these devices to speak the same language. Okay, and this is really important to have above just the basic, physical connectivity. So you've heard a lot about this elsewhere this week, and I'm not going to go into a lot more detail on that in this session. But it's just to know that it's important. Okay, so I'm going to talk about Wi-Fi in the home because it's the most ubiquitous connectivity out there today. We think it'll continue to be widely used. It's got IP-based interoperability, And it's got a pretty good intersection of performance and energy efficiency. And there's some new things that we're doing in Wi-Fi that'll push the envelope on this even further. But I'll describe some things that are out there today that we have. So we have a broad range of a very large portfolio, but I'm going to focus on two particular, well, really one device. I'm going to contrast it with a second type of device. At the top, we have a device that has a pretty powerful CPU in it. Today it's MIPS, tomorrow it could be ARM, could be something else. And it has a lot of memory space, and it has built-in Wi-Fi. It comes as a 2x2 or 1x111N. And it runs Linux. And so it runs OpenWRT, and a lot of our customers like to do that. They have ecosystems where they're using Linux across their ecosystem, and so this is a very attractive product for them. The other type of device is a thinner device, which has a smaller CPU. All the memory is internal, so it's not as much memory. And it runs an RTOS. In our case, we run ThreadX. You could actually run any RTOS on here, but we chose ThreadX for our productization. This version of it is a 1x111N, and it's designed to be very low power. It's suitable for battery powered devices, and I'll say a little more about that. So there's kind of two classes. There's the thicker device, runs Linux, a lot more flexibility, but additional cost. And then there's the low power, thinner device, which is good for, say, like a door lock. You might find in an appliance something like this, and maybe in a door lock something like this. You need a range of capabilities. Okay. So a little bit more about the 4004, and I'm trying to use this just to illustrate sort of the class of device that the industry is building. I mean, we build these, other people build these, but this is kind of where the industry is today. So power management is important. As I said, we want to run on batteries, and our target for this class of product is really AA batteries running for, say, 9 months to a year, in whatever use case you have. For example, a remote control, you don't want to replace the batteries every month, and you're not going to recharge it. Well, there are some that recharge, but generally, they run on 2 AA's for a year or so, and so that's the target. So we want to have very low power, so you can have battery operation, but we also need fast wake-up time. So again, for a remote, when I'm not using it, it lays on the couch for 2 weeks while I'm on vacation. You want it to be basically off. But I come back and I hit the button, and I want the TV to start right away, or when the TV's up and running and I haven't used the remote for a while and I press a button to change a channel, I want the Wi-Fi to come up very quickly, send a packet, get that channel change underway. Okay, so the Wi-Fi capabilities inside are, again, 1x1, 11N, pretty common. It's a dual band, supports 2.4 and 5 gigahertz. Supports a number of other of the Wi-Fi standards. We highlighted Wi-Fi Direct here because we're finding a lot of people use that in IoE devices. It's got antenna diversity, which gives you a little better performance for very little extra cost. And it has built-in power amps. So this reduces your cost of your solution. And then we provide with this solution, the all-join client is in here. So we support the control panel service, the onboarding service, and the notification. And of course, we have the all-join security in here. Security is very important for the IoE space. And we're spending a lot of time assuring that, at least at the chip level, we have all the security tools in there to enable the whole value chain, the whole system to be secure, because we're kind of concerned that if there's security breaches, crazy things like the FOSCAM baby monitor where somebody hacked the monitor, was yelling at the babies and waking them up, and that's kind of an annoying thing, but what can be even more draconian is you have a connected oven and it gets hacked, turn the temperature all the way up, you're not home, burns down your house, even worse, maybe someone dies in the fire. So when we talk to our customers about connecting devices, there's a healthy fear of the ramifications of connectivity if things are hacked. So security is a major consideration for us. And this is one of the good things about AllJoyn is because you can do a lot of things within the home. You don't have to go out to the cloud to do everything. And the more you do inside the home, overall, the more secure you're going to be because you have fewer pipes for people to attack your network. Okay. And then we have, and you'll see a little bit more about this, we have a full an integrated networking stack that runs on this device as well in hostless mode. Okay, so in addition to the silicon, we have, of course, you have reference designs and development kits. This is one that we have here. This is well, you'll see the demonstration of this in a little bit. This board has an MCU on it. Happens to be a Freescale MCU because a lot of our customers will design systems with an MCU that they want to use, and they will tack on our Wi-Fi chip as a client. So that's one mode. You got MCU plus a Wi-Fi client. And then for simple applications, this device can actually run hostless. So you can run, develop applications and run applications directly on that device. So something like a door lock, no problem to do that with just this device. If you want to do something a lot more complex, maybe an appliance where you got multiple motors and you got different sensors coming back, then you might end up being in the 2-chip MCU class. But you have a lot of flexibility as to how you go. And these modules are available from a number of vendors. They're available in high volume. They're all certified, regulatory around the world, Wi-Fi certified, so they're good to go. You get a hold of these and you stick them in your system, and you don't have to go do any of the certs. This product's actually in very high volume today, so it's a very mature product. And here's a look at the software architecture in the hostless version of it. So of course the Wi-Fi driver is at the bottom. We have a full IP stack. We got DHCP and DNS services. We got an SSL client server, again security, an HTTP client server, and then we built in the AllJoyn client up here as well, and then the user application sits on top here. So it's pretty conventional, but we cram quite a bit in this little chip. And then the tool set that's available, and this being a developers conference, we thought we'd talk a little bit about the tools and show you how they work. So the tool set that we use here is based on the Extensa Explorer tool set, which extends the CPU core inside. And so you got the ability to compile, link, debug, and analyze just like you would in any typical system. It's quite easy to use. Most of our customers program in C, so it's got an optimizing C compiler. It supports both a command line and a GUI development interface, and it's available for both Windows and Linux. So we're going to show you a demo here in a little bit. This is what you're going to see. It basically has two kinds. It's pretty flexible, but we're going to show you kind of the two main modes that people use. First of all, you create your source code. You got an editor here, and it's got your project folders over here, with source files, etc. And then from this mode, once you've got your source built, you can then go into what we're going to show you, the build active. We'll do the compiling and the loading down to the device, and then it'll run the device or run the program. Okay, and then when you're running the program, the debug environment allows you to you can see the processes that are running. You got the source file here. You can set your breakpoints directly in that source file, and then we hit a breakpoint. You can go over and look at variables and see what's going on with your code, and then you can move around to various different views. So here's the setup, and it'll just take a couple of minutes to do a quick demo for you here. So we got a laptop running. Sorry, I went. Okay, you switched over. All right. So anyway, there's a laptop that's running the daemon, and then there's a JTAG connector to our board, and then you'll see on the screen here, you'll see the actual code. So what he's going to do is there's a call here to go scan for the Wi-Fi, all the Wi-Fi access points out there. So the code was written before, right? So he's now just going to go and compile it and load it, and then he's going to run it, and we'll go into the debug environment. He's going to set a breakpoint. So when we stop, we can look at some variables, and you can see, oh yeah, there's a lot of Wi-Fi around here. At least there was. I hope they're still on. Okay. So now he's going to run it, and it'll come in and it'll hit the breakpoint, and then we'll be able to go look at at some of the variables and go see what access points are out there. So this is the output. So you'll see that you get the hex, but then it's translated to the ASCII as well. So let's see, what do we have? So there's an SSID uplink, and there's a whole bunch more of them. But so that's kind of the debugging environment. So it's pretty typical, but it's a pretty useful, easy to use tool that's available for this device. Okay. And with that, I'll entertain any questions.
How much does it cost us OCA4004?
404, well, it depends on volume, but those modules that I show you, those are typically available, in very high volume in the $4 to $5 range.
Okay, because I'm looking from developer point of view, I will buy 5 or 6.
Yeah. So you can buy these now. So we have a relationship with Arrow, the distributor, and well, there's two ways you can get them. You can go on the Qualcomm developer network, and there's links there. You can go through and you can get access to this development system. You can also get access to an Arrow development system, which is very similar. You can get access to the Wi-Fi modules. You can buy them one at a time from Arrow. You can buy volume from them. And I think their development kit is, that's about $30 or something for the development kit. So it's relatively modest. And then you can download all the tools from their website. So you get up, and we're trying to make it easy. Our business in the Wi-Fi business as it's grown up has really been hundreds of customers, where we tend to support them pretty directly. But in this business, because it's so broad, there's tens of thousands of customers, literally, and lots of activity, with the home hacker and the maker market, and so we've gone out to distribution so we can broaden out the access to people like that, because we can't afford to support somebody who's going to buy 10 models a year. Or even 1,000 modules a year. So this is a way to really spread the technology broadly and cheaply and easily. So there's a click-through license. You don't have to go through a big licensing process. It's just easy and low cost, and we hope a lot of people will use it. Yeah. Well, why Wi-Fi and not Zigbee or Z-Wave? Yeah. So those are some of the early. There's early traction there in the market, and probably some of that will keep going. We've been a Wi-Fi company. Maybe we do those at some point. I don't know, but we think for a lot of the applications, Wi-Fi is really the best solution. Partly for the reason I mentioned, where people are building out Wi-Fi networks in their homes, right? So if I have a Wi-Fi network, why put another network in there, right? That doesn't really do anything different than what I've done, than what Wi-Fi does. And we're driving the characteristics of Wi-Fi in terms of power consumption and cost down to some of the levels of those other technologies. There's a new technology that will be coming out in a couple of years, 11AH, just past draft 2.0, and that we think that'll get a lot of traction in the IOE type of space. And then there's for things like wearables, there's BLE. BLE is a big market for that. That'll be there. We kind of think of things. Anything that's in here, is going to be a lot of places. And what's in here? It's Bluetooth, it's Wi-Fi, and there'll be a few other things. But I don't think you'll see Zigbee in these things anytime soon, or Z-Wave. Yeah, I'm sorry, I can't hear you. Yeah. Why do you say that?
That's what I think.
Okay, so maybe that's a misconception. You know why it has longer range? Because they use mesh. They hop and hop. Zigbee, Zigbee is really 15.4. It's the radio. They're really separate things. Zigbee is a stack built on top of the 15.4 radio. 15.4 radio is in 2.4 gigahertz. There's actually a version that runs at 900 as well. But in 2.4, the radio characteristics are basically the same as Wi-Fi, right? I mean, it's physics, right? You got a power output level. It's a little different. It's different modulation, but it's not that different. And so it's physics. I mean, they both go just as far for the same power output, really. The reason that people say Zigbee has more range is because they have Zigbee's a mesh protocol basically, and so it allows you to hop from one device to another. And so if I have enough devices, I can hop to the end of my house. But if I put in these Wi-Fi extenders, which people are doing, it has the same effect. The Wi-Fi extenders aren't technically mesh, really, but they have the same effect. And you already have Wi-Fi for everything else. So now Zigbee probably won't go away. They can cohabitate, and that's fine because we have, when you get to the real problems up above the physical layer, where AllJoyn solves those problems, AllJoyn can run with Zigbee. So really with AllJoyn, you're PHY agnostic, you're OS agnostic, and so if Zigbee hangs around, fine, we'll still be able to connect all that stuff together with AllJoyn. Any other questions? Yes?
How about the PLC plus the Wi-Fi technology to build a home gateway?
Yeah, so that's being done today. We sell PLC as well as Wi-Fi. We're a pretty big supplier of PLC. It's used quite a bit. And there are gateways out there that include PLC. What we see more is adding on PLC as an accessory. So you'll either have a pair of PLC modules, and one you'll attach via Ethernet to the gateway, and the other you'll attach via Ethernet to the end device. That's pretty popular, but what's becoming really more popular is where one end is just PLC, you hook it into the gateway, and the other end is PLC plus Wi-Fi. We call them sprinklers, Wi-Fi sprinklers, and you just plug them into the wall, in a room. So let's say you have a Wi-Fi router and you decide, I want to use my laptop in this room, I've never used it before, and you go back there and it doesn't work. Well, if you go back to Best Buy or whatever and you buy one of these pairs, which they're sub $100, and they're getting lower, you connect one to your router, and you take the other one and you put it somewhere between your router and that room, or even back in that room. You just plug it into the wall, and it goes power line back to your router, and then it sprinkles Wi-Fi in that room. And it works great. That's what I use in my house. And there's a lot of those flying off the shelves now, so people are figuring this out. Yes?
Basically, all devices should be connected to the same wireless network, or can we? What do you mean? That all devices should be connected to the same access point?
Well, they don't have to be. That's probably the ideal way, but you can bridge networks. So again, go back to take Zigbee. Zigbee will have, if you buy a Zigbee network, you'll have a little box, that has the Zigbee radio in, and probably Ethernet connects to your Wi-Fi gateway. If you want to get the Zigbee stuff out to the cloud, you got to go through your gateway. So they have a little Zigbee gateway that hooks to your router to get out. And so you could bridge, in the router, you could bridge from Zigbee to Wi-Fi and go to all the other Wi-Fi things in your house. That's partly what AllJoin can do for you. Okay.
It means not just a root, it has to have some functionality to gateway the protocol.
Yeah, they typically do. They typically, you know, they're typically have IP stacks in them. Yeah.
Just like this one, not just the root is fine, not fine.
It varies by product. You know, it's manufacturer specific how much they want to put in, and if they want to bridge or not. I mean, I think most of the Zigbee boxes, I'm not real familiar with them, but I think they're pretty basic. They just want to connect to the internet, so they don't do any bridging. Yeah. Any other questions? Okay. Well, thanks for coming on a Friday afternoon.